All right, here we go, lesson 6-1. Hopefully you've got something to write some notes down on. This will be useful when we come to the quiz or the test. So today's title would be exponents and properties. Remember what an exponent is. I'm going to zoom into here. We have a number, and then sometimes we write a little number above it. This here we call the base, and this is the exponent. Okay? So we're focusing on the numbers that are above, so to speak, and to the right. And what special properties do they have? How can we manipulate them? First of all, a little bit of review. You might have remember PEMDAS. We have to keep that in mind as we go through and evaluate problems. It's going to be especially important, this chapter. So as we look at this first expression, we're going to look at, are there any parentheses? And sure enough, there's a parenthesis, so we'll do 14 divided by 2 first of all. Hopefully you remember that that's 7. Next, we're going to look at, are there any exponents? And we see 2 of them. There is one here and one here. So what does an exponent mean? Hopefully you've not forgotten that. It would mean that if I take a 3 to the 3rd power, I am multiplying 3 3s. So plus the 15 minus, and then I've got 2 9s here, right? 9 times 9. I'm going to put parentheses around those to indicate that we need to multiply those 2 things together and the 3 3s together. So I've dealt with my exponents, now I need to do my multiplication. So 12 times 7, I think it is 84. 3 times 3 times 3 times 3 is 27. And we've got a 15, and then we've got 9 times 9 is 81. So now we can add and subtract. My preference here is work left to right, yes? So PEMDAS, it's not like multiplication occurs before division. It's not like addition occurs before subtraction. These occur as they happen from left to right. All right? So 84 minus 27. I think that's going to give me 57 plus 15 is going to give me 72 minus the 81. I think I've ended up with -9 is my final answer. Hopefully all that made sense and you know how to follow those orders of operation. Okay? Trying another one here. Again, go through, I've got a parentheses, we do this first. So what is 10 minus 4 times 4? So let's see, that is going to be 10 minus 16, so I think I'm going to get a -6. Next I'm going to do my exponents, which is 2 to the 4th. So that means I have a 2 times 2 times 2 times 2. I've got some other stuff in front of this, but I'm going to ignore that for the moment. Okay, so 2 times 2 times 2 times 2 I think is 16 plus -6. And then I've got the -7 plus the 16 divided by the 16 plus the -6. So you can see kind of how that shapes out. And now, of course, we must do the division next. Okay. Yeah, 16 divided by 6 is 1. So this is -7 plus 1 plus -6. And finally, Negative 7 plus 1 is negative 6, plus another negative 6. I think I get a negative 12 in this case. All right, hopefully I didn't go too fast there, and that all made perfect sense to you. That is PEMDAS. One other little review idea here before we keep going. Do you remember the good old square root friend that you had back maybe in 5th grade, or not too sure when they introduced it to you? When we put that little square root around a 64, what does that mean? By the way, I tend to put a little tail to show where my square roots end. So the square root of 64, we're asking what number times itself is equal to 64. Right? So if I can write it this way, x times x equals 64. Well, you can do this by trial and error. You might remember that there are special numbers, squares of numbers, and you might remember that it's 8 times 8 is 64. So the square root of 64 is 8. I'm going to do one here with a negative sign in front. Again, what number multiplied by itself is 25. And we remember that 5 times 5 is 25. So the square root of 25 is 5. Careful, there's a negative sign in front, so we need to carry that negative sign in front here too. All right. And finally, this might be a new symbol for you here, the plus minus. It just means there's two numbers sitting there. So my answer in this case is, again, what number times itself is 121? You could check it on your calculator, like 10 times 10, what's that? 12 times 12, what's that? Eventually you discover that 11 times 11. So again, this is 11 and negative 11. So there's two answers sitting in that solution spot. All right, that was a little bit of review. And now for the properties. First of all, we have a zero property. If you haven't started writing at this point, I would suggest you do. So there is what we would call a zero property and a negative exponent property. The zero property says any number carried to the zero power is 1. If you're curious as to why that's true, I can explain that to you, why it has to be true. In some cases, if this is difficult, it's best just to have this down as a rule, and you just memorize it. The negative exponent is even trickier because you have to think of it as a division problem. So instead of a to the negative n, it's going to be a to the n underneath the 1. So I don't know if you remember an idea called reciprocals. So a negative exponent can be thought of as a reciprocal because, for example, 2/3, the reciprocal of that is 3/2. So if I take something to the negative 1 power, it's going to flip it, right? So for example, and we'll do some examples of this in just a moment, like 4 to the negative 1. Well, what's the reciprocal of 4? Well, it's not a fraction, so make it a fraction. And now the negative exponent will turn it into 1/4. All right, negative exponent. Here's some examples. Hopefully a negative exponent, or zero exponent doesn't throw you for a loop. You say, oh, yeah, that's just going to be 1. Always 1, doesn't matter what the base is. Here, be careful, we have negative 2 times itself 4 times. Hopefully you can see why I'm using parentheses in this case. The negative signs might make it look like a subtraction problem, right? Okay, so 2 times 2 times 2 times 2 is 16, because 2 times 2 is 4, times 2 is 8, times 2 is 16. And if we watch then the negative signs, a negative times a negative, that's a positive. This is a positive. And then these two together make a positive. So my answer is positive 16. And my first example is positive 1. Okay. And another example, example 2, simplifying an expression. Here, we have some variables, some letters showing up, and we're going to use the same property. Note we have a 0 and a negative. Which one do you deal with first? And what about the 4, right? Well, notice the 4 doesn't have any exponents. So the first thing we'll note is that the 4 stays by itself above where it is. Again, hopefully you haven't forgotten, a 0 exponent turns that x into a 1. Yippee. And all I need to worry about now is this -3 exponent. Now recall that a -3 creates a reciprocal. So that means if it was upstairs, it goes downstairs. And if it's downstairs, it goes upstairs. So this little -3 exponent is going to end up going up there and becoming positive. So I've got a 4 times a 1 times a y to the 3rd power now, because that -3 flipped it upstairs. Final answer, 4 times 1 is 4. Y to the 3rd is just y to the 3rd. Nothing to do with that. There is my final answer using only positive exponents. All right, let me go back up here and write another thing. I use language upstairs and downstairs. So that's what a negative exponent tends to do. It flips those things around on us. I'll do one of these little examples here. One more. So let's focus on number 4 here. 3 to the -2 times x to the -5, y to the 0. I'll give you a moment here to start thinking about that. Again, 3 to the -2. That's right, that negative exponent is going to make a reciprocal. It's going to flip it. So instead of being upstairs, it goes downstairs. So I'm going to put a 3 squared there. All right, now we got a x to the -5. So that will go downstairs as well. So times x, again, drop the negative sign. And then that y to the 0, which is downstairs, just turns into a 1. You may ask yourself, what's upstairs? Well, if there is nothing upstairs in a multiplication or division problem, that's just a 1. So we have 3 squared. Last time I checked, 3 squared is 9 times x to the 5th. And the 1 obviously disappears. So 1 over 9x to the 5th. Kind of tricky. All right? So these are the basic building blocks of exponents. We're going to build on this and add some more properties. If you have, so there's 3 more properties we need to jot down. If you have a to the n times a to the m, meaning your bases are the same but the exponents are different, the shortcut to this is a to the n plus m. So for example, 5 to the 3rd times 5 to the -1 is going to be 5 to the 3 plus -1. So that's 5 squared, so that's 25. All right, that is the multiplication of exponents properties. Some people call that the product, okay? But it's when you're multiplying with a common base. Same thing, but this time now when we are dividing with a common base, notice they both have a common base of a. So in this case, instead of adding, we subtract the 2 exponents. Okay? So x to the 5th divided by x to the -2 is, notice how I keep just the base, x, right? And then I do 5 minus -2. So 5, oops, working too fast there. 5 plus 2. Hurrah. One more. Hopefully you're still able to focus. Hanging in there. This last property is called the powers property. And when we take a power of a power, so this is an exponent inside of an exponent. A to the n carried to the m power, a to the n times n. So 5 squared carried to the third power means 5 to the 2 times 3, which is 5 to the 6th. Which I'm going to let you leave when this exponent starts to get kind of big, and by big I mean above 5. We tend to leave the exponent there. We don't say, okay, 5 times 5 times 5 times 5. What is that? Okay? All right. So some examples of this. 3 squared times 3 to the 6th. Well, that is a common base multiplying together. So what do I do with my exponents? We add them. So we get 3 to the 8th. Again, notice the exponent's big, so just leave it. The directions will typically say only as a positive exponent too. All right, if it's a smaller exponent, go ahead and multiply it out. Negative 4 squared, so we have a common base, hurrah. And we have then the 2 exponents, and you recall using our property of exponents up there by division, we have to subtract those 2 exponents. So 2 minus 7. Now last time I checked, 2 minus 7 is negative 5. Careful, that is not a positive exponent. So we then say, okay, negative 4. But that negative exponent, is where it gets really tricky, is going to send it downstairs. So I need to put it 1 over negative 4 to the 5th power. And now you're done. Let me write that just a little bit cleaner. And we need to use parentheses around the negative 4. Don't be lazy and leave them off, okay? And then an example using power of a power, z to the 4th power. Since you're taking it to another power, you can multiply those 2 powers together and get z to the negative 12. Don't get too excited. You're not done. Got to keep going. Got to get this power exponent downstairs. So we say z to the 12th under 1. Okay. That wasn't too clear. Let me clean this up a little bit. All right, so notice that negative exponent flips it downstairs. Okay, makes a reciprocal. Let me see if any of these examples here look good. How about this one here? Y to the 6 minus 7, which is again a negative 1. So that means it's 1 over y. You don't need to put to the 1st power, you could, but, all right? I think that's enough of that. Let me go to the tougher problems here where we end up with multiple pieces. Like for example, this first one, letter A, we have negative 1.5y times negative 1.5y. So you're multiplying negative 1.5 times negative 1.5. Right? It's really confusing to write this without dots look like multiplication signs. So, all right. So again, I can take my negative 1.5 times negative 1.5. My calculator, I think, says 2.25. Y times y. Be careful. Remember, each of those has an unspoken 1. So that's going to be y to the 1 plus 1, which is 2.25 y to the second. All right. So this 2, power of 2 applies to both of them. Yeah. And this 3 in example B is going to apply to both of them. And this 4 is going to apply to all 3 of those. All right. I'm going to go to letter C. It's a little bit more complex. Letter B is a simpler one. Here we go. So 3D to the 4th power. So this is going to become 3 to the 4th, D to the 4th, and 2 to the 4th. Notice how I can just share that power with everything inside. So this becomes 3 to the 4th power. Don't say 12. 3 times 3 is 9. Times 3 is 27, times 3 is 81. D to the 4th is just D to the 4th. And 2 to the 4th power, again, is 16. Make sure before you circle your answer that you check to see that you can simplify any more. We can't, though. It's done. I'm just going to start this example off. Notice how they said positive exponents. We've got a negative exponent here. Don't forget that negative exponent. What does it do? Let's go back to that rule. It makes a reciprocal. It flips things upside down on us. So here we go. First thing I'm going to do in this rule is I'm going to make a reciprocal. So this problem is going to turn into 3 over 2 to the x to the 5th power. So deal with that negative exponent right away or deal with it at the very end. Don't do it halfway in between. I wouldn't like to distribute that negative 5. I think that's kind of silly. So now put a 5th power on everything. So the 5 and the 3 and the x all to the 5th power. Okay. So we have a 3 to the 5th, and I think that is 243. Again, if you left that as 3 to the 5th, I wouldn't be upset. That would be an adequate answer. 2 to the 5th, I think, is something most of us can figure out without even a calculator. Multiplying 2 times itself 5 times, you just double every time, right? X to the 5th is x to the 5th. We just leave that as it is. So, really tricky working with powers. Here is an example. I am actually going to skip. Scientific notation. I think you got enough things to worry about in this particular lesson with exponents. Okay? Don't forget, this is where it all starts, the main properties, and then we have these additional properties as a result of that, multiplying, dividing, and powers of powers. Well, it was a long video. The next ones will be shorter. This one will take us a couple days to get through this lesson.